Welcome to the STEMIT Learning Program. STEMIT is a program that teaches mathematics, physics, chemistry, and biology. In short, STEM abbreviates science, technology, engineering, and mathematics. This program is available both online and on television. We offer the following: electronic books, PhET simulations, syllabus documents, and special educators. Now, let's see how this program runs with these simulations.
Hi everyone, welcome to grade 10 and grade 11 lesson, and also from D of course. For today's lesson we are going to deal with functions, and I know that in previous grades you did talk about types of relations, in which among them you talked about a special type of relation. So that type of relation, that special type of relation, which is a function. So today we are mainly going to focus on a function. So now, what is this function? Like I have said, that among the types of relations we have that special one, which is a function. We are saying it is special because for a function, each and every member of the input, remember the input, we used to call it x. So each and every member of the input, which is x, is mapped onto exactly one member of the output, which is what? Which is y. So I will say that again. A function is a type of relation where each and every member of the output is mapped onto exactly one member of the output. So below here I have diagrams, diagram A, B, and C, which demonstrates a function. When we look at diagram A here, we have our inputs here. Our inputs being P, Q, and R. So each and every element of the input here is mapped onto exactly one element of the output. Let's confirm that. We have P, which is mapped onto M. We have Q, which is also mapped to N. We have R, which is mapped to N. So as you can see, each and every element of the input here is mapped onto one element of the output. So this relation is a function. So let's go to diagram B. For diagram B, we also have our inputs being P, Q, and R. So also P is mapped onto X, Q is mapped onto Y, and R is mapped onto Z. So as we can also see here, our inputs here, each and every input is mapped onto only one element of the output. So that says this relation is also a function. But let's go to C. For C, we have P, which is our input, which is mapped to X, and also we have Q, which is mapped to Y, and also mapped to Z. So remember what we said about the relation, about a function, sorry. We said every element of the input should be mapped onto exactly one element of the output. So for Q here, it is mapped onto Y and Z. So it is not mapped onto one element of the output, but it is mapped to two elements of the output. So this one is not a function. So only A and B shows what a function is. Okay, so I want to believe that is clear. Now let's continue. We have different ways of showing, or we have different ways of which we can use to denote or to show a function. So that is a function notation. Now the most popular function notation that we normally see or the one that is mostly used in our textbooks, is f of x. So this is how we denote f of x. And how do we read that? We say this is f of x. So, however, f of x is not the only variable or letter that can be used to denote a function. We can also maybe have g of x or h of x, or even we can have b of a. So not only f of x can be used, we can use different variables or different letters. So here we have f of x being equal to 2x, or 2 multiplied by x. So what is this f in our function? This f is the name of a function, and this x here is our input. And also we have 2 multiplied by x here, which is our output, or we can say this tells us what the function is going to do. So in this case, the function is going to multiply 2 by our input, which is x. So like I said, we can also maybe have a h of what? H of x as the function notation. So in that case, it means h is the name of our function, and also x is our input. And also if we have g of x, g is the name of our function and x is the input. Also with b of a, b can be the name of the function and a will be our input. So we can also show f of x equals to 2x in this way. So in this, we say f is such that we say f is such that x is mapped to 2 multiplied by x. I will repeat. In this one, we say f is such that x is mapped onto 2x. So these are 2 different ways in which we can show our function. Okay, let's continue. Now that we have talked about the function, we have tried to show what a function is, and also we did show how we can denote, or we did talk about a function notation. So now let us go to how we can evaluate our function. How can we evaluate our function? So there are some few steps that we can follow when evaluating a function. So to evaluate a function, we substitute the input. Remember, in our function notation, I did show you what an input is. So we substitute the input, which can be the given number or an expression. Then we substitute it for the function's variable. That is, remember, in our function f of x, now in place of that x, we can place our input, which can be the given number or the expression. So we replace that x with the number given or the expression given. Then after that, we can work out our function. So that is how we can simply evaluate our function. Let us look at this simple diagram here. We have our function here, which we used to call a machine in previous grades. So to evaluate a function, we put our input in the function or in the machine. Then the function or the machine will work on that input and then gives us our output. So now we will have few examples on how to evaluate a function so that we can apply the steps that we did talk about here. So we have example 1 here. In example 1, we are given the function f of x, which is equal to 3x minus 5. Our function f of x equals to 3 multiplied by x minus 5. Then we have to find the value of f of 4. Okay, in this case, you'll be aware that instead of f of x, now we have f of 4. What does it say? It says that in place of x here, now we are going to put 4, because now we have f of 4 instead of f of x. So in our function f of x equals to 3x minus 5. Then in place of x in this function, we are going to put what? 4. Let's do that. Like I said, we substitute 4 into the function in place of x. So that says we are going to have f of 4 being equal to 3 multiplied by 4. Remember, in our function f of x, we have x. So in place of this x, we put what? We put 4. That is why we have 4 here. So we are going to have 3 multiplied by 4 minus 5. Then 3 multiplied by 4 is going to be 12. Then 12 minus 5 is going to be 7. That is how simple we can evaluate our function. We simply put the number that is given in place of x in our function, and then work out or evaluate our function. So let us go to the next example. In this example here, we have our function f of x being equal to 6 multiplied by x minus 1, or 6x minus 1. So now find f of 5. So the same thing is going to apply here. In this case, instead of x, we have what? We have 5. So that says in our function f of x equals to 6s minus 1. Then we are going to put 5 in place of x. Let's do that. Okay, we have we have f of 5. We have f of 5, which is equal to 6 multiplied by 5. Where do we get this 5, or why do we put this 5 here? It is because we said we are going to substitute our number 5 in place of x in our original function. In our original function, we had 6 multiplied by x. So in place of this x, that is where we are going to put what? 5. So that is why we can see here having 6 multiplied by 5 minus 1. So 6 multiplied by 5 is going to be 30, and then we subtract 1 from 30, then we get f of 5 being equal to 29. So even here we have simplified our function. We have evaluated our function f of 5 to get 29. The next example. Okay, next example we have, in this case, instead of f of x, we have different letters, h and z. Like I said earlier that not only f and x can be used in our functions. We can use different letters. That is why here we have h of z. h of z being equal to z raised to the power of 2 minus 4z plus 9. So we have to find h of negative 3. So in place of z in our function h of z, we are going to put negative 3. So we have h of negative 3 in place of z. Then being equal to negative 3 raised to power of 2 minus 4 multiplied by negative 3 for z plus 9. So let's evaluate this, or let's work out this. We are going to have negative 3 squared, or raised to power of 2, which is minus 3 multiplied by minus 3. Negative multiplied by negative, we are going to have positive, and then 3 multiplied by 3, we are going to get 9. Then we have negative 4 multiplied by negative 3, then we are going to have positive 12. Why positive? Positive because negative multiplied by negative is going to be positive. Then we have plus 9. Then we just add 9 to 12 and then to this 9. Then we are going to get 30. So this is how we can simply evaluate this function. So this is all you have to do when you want to evaluate a function. So in our lesson here, we just talked about a function which is a special type of relation in which each and every element of the input is mapped onto exactly one element of the output. And we did also talk about how we can evaluate our function. So we said that to evaluate our function, we just put or substitute the given number or maybe the given expression in place of x in our function, if maybe our function is in the form f of x. But if it is in the form of maybe h of z, like the last example that we performed, then we substitute that number or that expression in place of z. Then after substituting, you just work out that function. So that is how we can simply evaluate our functions. So I want to believe that you did enjoy our lesson and you have understood all the steps that you need to do to evaluate our function. Thank you.
Thank you for watching today, and please contact us on the information below.